Well friends, from the chapter Alcohol, Phenols and Ether, today we discuss about the alcohol, its physical and chemical properties. Alcohol contains OH group, which is also called functional group. When OH group is attached to aliphatic carbon, it is called alcohol, and when OH group is attached to benzene ring, it is called phenol. Here are few examples of alcohols, that is ethanol, menthol and cholesterol. Let's start with the naming of alcohol. In IUPAC name, first select the longest chain which contains OH group and give minimum number to that carbon atom which contains OH group. For example, in this particular, the name of the compound is 3-hexanol. When some side chains are given, then first write the name of side chain and then the longest chain which contains functional group. In particular example, the name of the compound is 2,4-dimethyl 3-hexanol. When in case of phenol, the OH group is attached to benzene ring. The name is phenol and counting is done from the carbon which contains OH group. The second one is 4-bromo-phenol and third one is 2,4,6-tribromo-phenol. Alcohols are also classified on the basis of primary, secondary and tertiary alcohols. When OH group is attached to primary carbon, it is called primary alcohol. When it is attached to secondary carbon, it is called secondary alcohol. And when it is attached to tertiary carbon, it is called tertiary alcohol. For example, 1-propanol, that is primary alcohol, 2-propanol, secondary alcohol, and 2-methyl-2-propanol is tertiary alcohol. Now, in physical properties, as we know, OH group is a polar one and it is capable of forming hydrogen bonding. This makes alcohol soluble in water. Alkanes, which has larger carbon atoms, are less soluble in water. Here is a graphical representation which shows as number of carbon atom increases in alcohol, its solubility decreases. For example, butanol has maximum solubility as number of carbon atom increases from pentanol to hexanol to heptanol. Its solubility keep on decreasing. The OH group present in alcohol also forms hydrogen bonding, which affects its boiling point. If we have alkane and alcohol with same molecular mass, the boiling point of alcohol are greater than corresponding alkanes. Here in this graph, it is clearly shown that alcohol and alkanes having same molecular mass, the alcohol has higher boiling point in comparison to linear alkanes. Let's study reactions of alcohol. The first one we study the dehydration of alcohol. It is done in presence of sulfuric acid and temperature range between 170 to 180 degree. It is also called elimination reaction. In this reaction, the OH group from the carbon is removed and hydrogen is removed from alpha carbon atom and we get corresponding alkene. Here are a few examples. In case of 2-propanol, when it is subjected to H2SO4 sulfuric acid at temperature 180 degree, we get propane. Now, second one is a very interesting example. In case of butane 2-ol, when it is subjected to dehydration, it contains 2 alpha carbon atoms. We are getting 2 products, that is 2 butene and 1 butane. Now, question arises, which one is the major product? According to Sertsev rule, as we know, the most substituted alkane is the major one, and in this case we get 2-butene as a major product and its formation is 90%. Let's study the dehydration of alcohol mechanism. Dehydration of alcohol follows 3 steps. First one is protonation of alcohol. In this, proton from acid attack on oxygen and we get protonated alcohol. It is a charged species and unstable. It loses water molecule and we get carbonium ion. This step is called formation of carbocation. Now in third step, this carboketone loses H positive ions in presence of hydrogen sulfate, and we get corresponding ethene along with the formation of H2SO4. In this reaction, H2SO4 not only initiates the reaction but it also acts as a catalyst. Now, at 140 degree, dehydration of alcohol takes place, but in this case, two alcohol molecule loses water molecule to form ether. For example, in ethanol, when it is subjected to 140 degree temperature and treated with H2SO4, we get corresponding ether, that is triethyl ether. Now let's study oxidation of alcohols. Oxidation of alcohol is carried out in presence of oxidizing agents such as potassium dichromate and potassium permanganate. Primary alcohol gives aldehyde, which further on oxidation gives us carboxylic acid. Secondary alcohol gives us ketone, and tertiary alcohol do not go any reaction. This happens at room temperature. Here is the examples. In primary alcohol, when it is subjected to oxidation, we are getting aldehyde, which on further oxidation forms carboxylic acid. Secondary alcohol gives us ketone, and tertiary alcohol do not give any product. Here is a experimental verification. If we take two test tubes, one contains ethanol and second contains oxidizing agent like potassium dichromate, and if we add potassium dichromate to ethanol, the ethanol gets oxidized and chromium is reduced, forming a grayish-green precipitate. To summarize the chemical properties, here is a flow chart which gives us all the reactions of alcohol which we have covered just now. Alcohol in presence of H2SO4 undergo dehydration, and at 140 degree we are getting ether, and 180 degree we are getting alkene. Alcohol on oxidation, we get aldehyde in case of primary alcohol, and which further oxidizes to give us carboxylic acid. Secondary alcohol on oxidation give us ketone, and tertiary alcohol do not go any reactions. Thank you.